Okay, so the question is, I think something like, if you have a circle and you have a line, show that the solution set could either be nothing, or 1 point, or 2 points, right? Right. Okay. So geometrically, this is obvious, right? You know that a line's going to intersect a circle. Either it doesn't intersect it, or it hits it tangentially, right? Or it hits it tangentially, or it doesn't hit it or it intersects it but not tangentially, in which case it hits it in 2 points, right? So geometrically, it's completely obvious. And they're asking you, can you see this algebraically, right? Can you see this algebraically? Was anybody able to give some sort of reason, algebraic reason, why there ought to be 2, 0, or 1 solutions for this equation?
Well, I don't know if this is right, but for 2 points, I did, so they gave us the line y equals 2x, and then I wrote a standard equation for a circle as x squared plus y squared equals r squared, and then I plugged in 2x for y.
Great. Yeah, so exactly, right? So they give you some circle, I don't know what it was, x minus a squared plus y minus b squared equals r squared, and they also give you a line, right? Y equals 2x. Right? But it could have been any line that they gave you, right? And they say, okay, well, if you're looking for the solution of these two things, you want both of these things to happen, right? You want the points for which both of these happen, and so you can play the game of taking this one and substituting it to the next, and then solving to see where it does happen, right? So right, you're solving two equations. So let's require that y equal b2x by saying let's let y equal 2x, okay? And then let's put that in here. So we get 2x minus b squared equals r squared, x minus a squared. Okay, so you end up with this equation, right? This equation here, right? And then what can you say about this equation? Is there some reason why this equation ought to have 0, 1, or two solutions? Suppose let's make these some concrete numbers. 1, 2, 3. Okay. Is there some reason? Well, I'm going to keep them as is. Sorry. Okay. Well, no, I'm going to switch them back. Okay. Suppose I give you this, right? How would you find the points where this is valid? How would you find it? Suppose I say solve for x. What x make this equation true? How would you find the x? All right.
Oh well, like x could be 1.
X could be 1. Is that true? I don't know.
Oh no, it's not.
Okay. But how would you solve it? Let me write it down. The bigger x squared plus 2x squared minus 2x plus 1 plus 4x squared minus 8x plus 4 equals 9. Right? And somebody says, what's the solution to this? How do you solve it? You can do it. You've been through junior high school. Right? You use quadratic formula, right? This is a quadratic, right? This is a quadratic, and so the solutions are going to be right of a particular form. What are the possibilities for the solutions of a quadratic equation? How many solutions can you have? You could have 2. You could have 1, or you could have 0, right? If b, right, you do the quadratic equation, negative b squared plus or minus the square root of negative b plus or minus the square root of b squared minus 4ac over 2a, right? You use the quadratic equation on this thing, and depending on whether or not this is, right, if this is 0, if this is a negative number inside here, right, if b squared minus 4ac is negative, then no real solutions. Right? You end up with two complex numbers. Right? If it's equal to 0, then you have one solution. Right? You have one solution. And if it's bigger than 0, then what happens? You have two solutions, right?
Does it matter that the solutions could be positive or negative? It's like plus or minus.
I'm not, say one more time.
Or like, don't you get plus or minus your solution?
Uh-huh.
Does it matter that it's plus or minus, like positive or negative number?
No, because you're just going to get up, you're going to have x, is, something like, if you write this out, so what is this? 5x squared minus 10x plus 5 minus 4 is equal to 0, right? So the solutions are going to be, 10 plus or minus the square root of 100 minus 4 times 20, so 80 over 10, right? So your solutions here, for this example, saying your solutions would be 10 plus or minus the square root of 20 over 10, right? And so those would be your x values, and then your y values would be twice your x values, right? So in this one particular example, you'd have two solutions. But depending on how these numbers are chosen, you could have one solution or you could have no solutions. And that's the point, right? That the solutions for the points that satisfy a line and a circle, the x values solve a quadratic equation, right? Since they solve a quadratic equation, you know that the possible number of solutions is either nothing, 0 solutions, 1 or 2. Okay, so this is how you see. If you had no geometric sense at all, you could still see that a line intersect a circle is either going to be, there's either going to be no intersection, one intersection, or two intersections. That's sort of the point of this question. Does that answer your question, Mariah?
Mm-hmm.
Yeah. Okay.
Yeah.
Oh, yeah, go ahead.
Can you explain how you got to this, how you implemented this quadratic formula?
How you get the quadratic formula?
Yeah, I just don't understand how you have the full formula and then we're plugging it into something different.
You mean like B, A, and C, like what we
Yeah,
said?
I don't understand that.
Do you mean
Like what you plug in for B.
what's B and what's?
Mhm.
Oh, okay. So let me see if we're actually going to do it in a backwards way. Let me just state it for right now. So if you have so maybe you know this already, but I'm just going to say it. The equation ax squared plus bx plus c equals 0 has solutions. So this is the quadratic formula. The equation blah has solutions of the form x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so for example here, right, we have this equation, and so its solutions are going to be, negative b, that's 10, plus or minus the square root of 10 squared minus 4 times, oh, this should be plus, right? Minus 4 times 5 times negative 4. This should be a plus. Divided by 2a, so that's 10. Right? So the solutions, looks like this. These are the solutions. Now, as for why that happens, I don't know if you're asking why that happens, or are you asking why that happens?
No, you don't back which one again.
Okay. So but I'm going to tell you anyway. As for why that happens, you can actually figure it out by using completing the square. You say, well, look, I've got this thing, x squared plus bx plus c equals 0. I can simplify that by dividing by a, b over ax plus c over a equals 0. Right? you can give an equation. You don't change the solution set by dividing by some positive number, by some non-zero number, right? And here I'm going to use completing the square. Here I'm going to use completing the square, right? So this is going to be x minus b over 2a quantity squared minus b over 2a squared plus c of a. Yes, Stefan.
Completing square, you change the sign on the first parentheses.
I'm sorry, this should be a plus.
Oh, okay.
Thank you. You caught me. Yes.
No, I was just, I had it in my notes last time and I went crazy trying to figure out why. And now I know.
It was false. Okay, so yeah, if I had something like that before, it was wrong. Okay, so this is right then. Okay, and then you say, okay, let's move this thing to the other side, right? X plus b over 2a quantity squared is equal to b over 2a quantity squared minus c over a. Right, let me spell this out a little. B squared over 4a squared, right, minus c over a. Okay, and then, right, let me find a common denominator. You know, multiply by 4a on the bottom and 4a on the top. So that tells us that x plus b over 2a squared equals b squared minus 4ac over 4a squared, right? And you see that that's where the solution to the quadratic equation pops out of there, right? You take the square root of both sides. X is going to be negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So completing the square gives you the quadratic equation, in case you were wondering. Okay. You don't have to know that. That's sort of that's something that, I mean, this is maybe filling in a hole that you might have had when you first were introduced to the quadratic equation. But welcome. How do you say your name, please?
Riemann?
Riemann?
Yeah.
Okay, very good. It's almost like Riemann, the great German mathematician. Okay. Okay, so now let's get to the actual topic of the class for today, which is lines. Of course, you've seen lines before, right? You know, sort of geometrically, you already have a geometric notion of line. That's sort of a huge assumption, but I'm going to make it. You have some sense of what a line is geometrically, right? It's something that is straight and goes on. This is horrible, but right? It's something that it looks something like this, right? Okay. That's horrible, but we're gonna say that. Okay. I'm gonna assume that you have some sense geometrically of what a line is. Okay. So the question is, now that you have, the question is basically, how do you describe lines algebraically? And again, this is something that you know already, but we're gonna reconstruct it. So, okay. So the first notion is that a slope. So now that we have coordinate system with our coordinate system, one can define the notion of slope. The slope of a line. So you have some line, and now that we have coordinates, you can talk about the coordinates of 2 points on the line. So pick 2 points on the line. Pick 2 points on the line, and then we say that the slope is usually denoted by an m for some reason, historical reason. The slope m of this line is what? B. Mm-hmm. y2 minus y1 over x2 minus x1. Right. So it's the ratio of the change in y to the change in x, right? Ratio of the change, of the vertical change, right? The vertical change to the horizontal change. Okay, and it's geometrically, right? It is, you take your 2 points and you make a right triangle, right? And you have this thing, the change in y, and you have this thing, the change in x, right? And it is the ratio of the change in y of this leg of the triangle to this leg of the triangle, right? It's the sine ratio of the legs of the triangle. Right, so some of these, if this is negative, you could have, you're allowing negative numbers for this, right? It could be, right, if it's like this, then your change in your y is negative. Okay, right, so change in y, and your change in x. One uses, if you're not familiar, this delta y is, the delta is used to signify change. So change. Sometimes people will say, well, what is the delta? Like when I applied to a different job at another place, they said, well, the delta here is greater. The delta we induce in our students is greater, right? In the sense that they were a school that people would come in and after they came out, they could find really, the difference between the lives before they entered and after they entered was significant, quite significant. So that was how they described a good quality of their school. Okay, so let me ask some questions. One, does it matter if we change the order? Does it matter if we change the order of the points? Stefano?
No, as long as you do both.
Right. We'll change the order. Yeah, that's right. So no, because then you would get y1 minus y2 over x1 minus x2, which is the same thing. Right. Question number 2. Does m change if we take 2 different points? So here's the line. We've calculated m using x1, y1, x2, y2. Suppose we take 2 other points and calculate m using that. Does m change? Does it matter? No, it doesn't. Why doesn't it change? Slope is constant? Why is slope constant? Because the line is straight. Can somebody give me a Victor?
Because the ratio between the change and section.
The ratio is going to be the same? That's like saying the slope is the same? You're all sort of saying the same thing, but you're not convincing me yet?
Well, if you switch it around so you get negatives on both top and bottom, that would become positive, so it's like having an absolute value.
Sure. So that answers the first question, right? If you change the order, it doesn't matter. But what about the second question? Why doesn't it matter if you take a different pair of points out of?
Because if you do the triangle, the sides will always be proportional. Doesn't matter how long the hypothesis.
Okay. So you could say the ratios are going to be the same because of similar triangles, right? Because of similar triangles. Like these triangles are similar, and I guess we're sort of invoking some geometry here, right? But yeah, these are similar triangles, and so the ratio of the side lengths are going to be the same. So yeah, the slope really is well defined. It's not like if we change the points, we get a different slope. No matter what pair of points you choose, you're always going to get the same ratio. Okay. So yeah, there's no, and the way one expresses this is to say slope is well defined. Well defined. That it would be poorly defined if you said, I define the slope to be this ratio, and it turns out that when one person measures it and another person measures it, they get completely different answers. That would be a poorly defined concept, right? What we're establishing here is that it doesn't matter who takes the measurements. It's gonna as long as you do it correctly, you're gonna get the same. So slope is well defined. Okay. Okay, so now let's talk about the general formula for a line. Okay, so somebody gives you a line and says, how do you describe, and gives you a point on the line, how do you describe, say the slope, how do you describe this line? How do you describe this line? Okay. So how do you describe the points x, y on this line? I think that's a little bit poorly worded, but go on. See if I can fix it once we realize what's wrong with it. Let's see how we describe the points on this line. Well, we make an observation that if I take any point x, y on this line, then I know that y minus y naught over x minus x naught is some value m, right? And right, that there's what we just said is that there's some value m that for which this holds true for any points x, y, right? So for any, let's say that say that you have some point and say that the slope, call the slope m. So you have some point and you have some slope, and you observe, here's what you do. You observe any point on the line satisfies y minus y naught over x minus x naught equals n. Right? If you know this point and you know the slope of the line, well then, if I take any point x, y, right? If I take this x, y, whatever x, y I choose, y minus y naught over x minus x naught is going to be that m, right? Okay, so so this is going to happen no matter what point. Okay, so one expresses that. One multiplies through and gets this thing, right? So I should say, and vice versa, right? If the point satisfies this relation, then it's also going to lie in the line, right? And so this gives you a description of the line. It says this is the equation of the line, right? This is the equation of the line. We're looking. The line is right? The line is all xy such that y minus y naught equals over x minus x naught equals m. That is y minus y naught equals m x minus x naught. Okay. And so this is the point slope formula that you've seen before. Right. Point slope formula of the line. Any questions? Any questions about that? Right. So this is what this is. You've probably seen this before, right? If you have a slope, if you have a point on the line and you know the slope of the line, then every point on the line is going to satisfy this formula. This is how you see it. Yeah, Clint.
So are there any, other than the slope, are there any numbers that we need to have that are true for every?
So, I mean, this is, if somebody gives you a point on the line and somebody tells you the slope of the line, you can write down the formula for the line. So if I say, here's a point phi 3, and it has, the line has slope 2. What's the equation for the line? You'd say, well, the equation is going to be y minus 3 equals 2 x minus 5.
Okay, but that can change depending on whatever point you're given.
Yeah.
Okay.
Yeah. So if somebody gives you a different point or a different slope, then the formula is going to change.
Okay. But if you have a point on the same line,
Yeah.
the formula will still change, but it'll be the same line.
That's right. That's
Okay.
right. That's right. So, if you could have a different expression giving you the same line, right? If you took a different point on the line, you're going to get a different expression, right? But it'll still be the same line, even though the description is different. At least it'll look different. Other questions? Okay. Okay, so I'm going to assume that you're all familiar with lines. I'm sure you've seen lines before. You all have pre-calculus. Let me. So I'm going to assume you can line the equation of a line given point and slope, or given 2 points on the line. I figure you can do that. So, for example, if I give you a point A0 and 0B, take half a minute and write down the equation of this line. Write down an equation for this line. Okay, turn to somebody next to you and talk a little bit.
was about to say, I think it's like 0 miles in. Yeah. Oh, you didn't. Yeah, okay. I'm going to go say yeah.
Okay, who would like to tell me how to do it? 0, A, and B 0. Oops, A 0, A 0, and 0, B. How do you do it? Sabrina?
You can find the slope using 0 minus b over a minus 0.
Okay.
Negative b over a.
Okay, great.
And then plug that into the point slope formula.
Okay, which point do you want to use? This one or this one?
A comma 0.
A comma 0, okay. So you get one.
Y minus 0 equals negative b over a times x minus
X minus A. Great. Okay, that's good. Right. Okay. Great. So that's good. Let me. You can also let me go a little bit further, just to bring out one thing. You could write this like this. Let's divide both sides by b. Y over b equals negative x minus a. Negative x minus a over a. Right? That's to say negative x over a plus 1. That's to say x over a plus y over b equals 1. Okay. Just to make a nice symmetric form. So this is called the intercept form of a line. It's not. Don't worry about it. It's not that important. It's just something. Along the same lines, if I have 0b and m, then what's the equation of this line? Go ahead. Y equals mx plus b, right? Let's work it out in a slow way. So I'm going to say y minus b equals m x minus 0, right? Using the point slope form, right? And then you see that that's y equals mx plus b. Right. Okay. So for some reason, people get in the habit of liking the slope. This is the slope-intercept form. You all seem to, students tend to switch everything into the slope-intercept form, even if there's no reason to. Try to rid yourself of your attachment to the slope-intercept form. There's no reason to prefer this one point. So, for example, often if I give this sort of thing could happen. Like I give a point here, and I give the slope, and I say, what's the equation for this line? And instead of using the point slope form with this point, for some reason people always switch it into the slope-intercept form, even though it's just extra work. Okay, so I'm not sure. Of course, this is because this is what you're used to in. I think probably the first form you're introduced to in junior high school is the slope-intercept form, but there's no particular reason that one should be preferred. Okay. So all that stuff that we've just been doing is sort of easy. You've seen a lot of it before. Here's something a bit more interesting. So if you have two lines, suppose you have two lines. Okay. Let me change a little bit. Suppose you have two lines, line 1 and line 2, line 1 and line 2, and you know that the slopes has slope m1, and the slope of this guy is we're going to call that guy's slope m2. Okay. What can you say about m1 and m2? Does anyone know this relation, Mariah?
M2 is negative 1 over n.
Okay. Okay. So if L1 is perpendicular to L2, then the product is negative 1. Right. Product of the slopes is negative 1. So here's let's see if we can figure out how that happens. Why is that true? Why is that true? Here's one cute way of seeing that that's true. Okay. So you say, okay, I'm going to take my lines and I'm going to slide it around until the intersection lies at the origin of my plane. Okay. Or just say you're going to put coordinate axes on the plane so that the origin is at that intersection. Okay, and let's walk over 1 unit on the x-axis. Let's walk over 1 unit on the x-axis. Okay, and I'd like to know what this length is. What's the length of this segment? What's the length? Oh, so in this picture, let's say that M1 is positive and M2 is negative. Okay, so I'd like you to answer me the question, what are the lengths of these segments? So take a minute and see if you can tell me what the lengths of these segments are, or half a minute. So. Okay, what's the answer? Okay, forget it. Gonna walk around the clock. Maybe talk to each other. Talk to somebody next to you. Okay, so what's the answer? What's the length of this one? Kelly?
So whenever the intersection is at line 1 equals, well, x equals 1, wherever that point is, that the line that we
So, okay. So hold on for 1 second. So this length is 1. This length is 1, right? And the slope of the line is m1, right? In other words, the ratio of the vertical change to the horizontal change is m1. The horizontal change is 1. The vertical change must be m1. That's the meaning of the slope. This is 1. This length had better be m1 because the slope is m1. Okay. Okay.
How did you know that was 1?
I just chose it to be 1.
Oh.
We said it was 1 earlier.
Oh.
I may have said it too quickly.
Minus.
We walk out 1 length here, and we're gonna put a bar there. We're gonna drop a perpendicular down like this. Okay. What's the length of what's the coordinate of this, what's the y coordinate of this point here? Or maybe I should say, what's the length of this thing here? You're all scared. Why are you scared? M2, right? Well, I mean, this is going to be 1 comma M2. M2 is a negative number, right? M2 is a negative number, so this length is going to be negative M2, right? This length here is negative M2. Right? The absolute value of M2 is negative M2, right? Because M2 is negative. Okay. 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 And then, okay, everyone all right? Everyone all right? Some people are laughing. I'm not sure why. Or maybe you're just smiling. That's good. Okay. Okay. So now we go crazy with the Pythagorean theorem. So maybe I should write that. Now we go crazy with the Pythagorean theorem. That's actually not true. We don't go that crazy. But we make some observations. We say, well, look, we have here a bunch of right triangles. Right? We have this little right triangle here. We have this triangle here. And we have this triangle here. Right? These 3 triangles are all right triangles. And so we're going to use the Pythagorean theorem a lot. Right? We say, applying to the little triangle, right? This is 1. This is M1. Right? So this, we know that we know that this is negative M2, right? So this length is going to be the square root of 1 squared plus M1 squared. M1 squared. This length is going to be the square root of 1 plus M2 squared. Right? And what we see is that a squared plus b squared equals, right, this length is m1 minus m2, is c squared. Right? So a squared plus b squared equals c squared. Yeah, Claire.
Why isn't it 1 minus M2 squared?
Because you get a squared plus b squared.
Oh, so it's going to be positive.
Yeah, it becomes positive. Negative m2 squared. Negative m2 quantity squared.
Okay.
Positive. And so by the Pythagorean theorem, again, you see that a squared plus d squared equals c squared.
With M2, why do you put it negative? Because I know that like the slope itself is negative, but if you put M2 as negative, wouldn't that like kind of cancel out?
Negative m2 is a positive number. Right.
What?
Negative m2 is a negative number.
Yeah.
Negative m2 is a positive number.
Yeah, exactly.
Right. So that's the length of this.
Oh,
of this
okay.
thing. Right.
All right.
It's true that m2 is a negative number.
Yeah. All right. Okay.
Okay. And then you just follow your nose. Like 2 plus m1 squared plus m2 squared equals m1 squared minus 2 m1 2 plus m2 squared. These guys cancel out, and you get negative 1 equals m1 m2. Yes.
Where did you get that negative
So negative 1 because I'm left with, at the end I'm left with 2 equals negative 2 and 1 2. And then I divide both sides by negative 2. So Is this cute? This is something that we would call cute. In fact, I didn't know this argument when I was teaching at someplace. No. About 10 years ago. Yeah, about 10 years ago, I gave a talk. That's right. Okay, so I gave a talk at the University of Minnesota, and afterwards, the people who attended the seminar to listen to the talk went out for dinner, and for some reason, the person sitting next to me said, "Oh, do you know the argument that shows that two lines are perpendicular?" I said, "No, I don't." And he said, "Oh, it's very cute," and then he explained it to me. And this is what we talk about. This is what people talk about when they have nothing else to talk about. That's not all we talk about, of course. Okay. Okay, so there's one last concept in this. Are there any questions? Any questions? Asha? No? So there's one last concept in this section, and it's sort of introduced at an odd time. So I'm going to just sketch it quickly. It's called least squares lines, or regression lines. Okay. So, I mean, it's an important question. If you have a bunch of data, suppose you've collected some bunch of data. Say these things are, you have all these things up to xn, and the heights are. So these points are x0, y0, x1, y1, x2, y2, x3, y3, etc., etc. So you have a bunch of points, and the progression is vaguely linear, and you'd like to have a line that approximates the points. Okay, you want a line that somehow well approximates this data. Okay, so it is possible to create or to find a sort of best line. Best approximating line. Okay, and that line is called the line of least squares. And I think they sort of sketch out how it's done. They give you a formula to do it. But let me just tell you what they mean by best. Okay, because this is the important thing. What do you mean by best? Is it, in what sense is it best? Okay, it's best in the following sense. Take a line, and then from each point, see how wrong the line is. See how wrong the line is. So measure this difference here. Measure this difference here. Measure this difference here. Measure this difference here. At each point, see how wrong the line is. Okay. And then we're going to add up all these errors, but we're going to do something funny first. We're going to square each error. We're going to square each error, and then we add all those things together. Okay. In other words, we are exactly taking these sums of the areas of these squares. Okay. So this best line is in the sense that the sum of the squares of the errors is minimal. So there actually is a line that has the smallest square error possible. Okay, and the book gives you a formula to find it. But I think the most important is that you understand what it means, what we mean by white by best. And this way of approximating data, you'll see in economics, you'll see in science. This is a very common thing. Okay, so that's it for today. Thanks.